So here we have about 20 different questions. So if I go up and down, and they are related to fractions, various conversions, prefixes, and significant figures. So I will knock all of these questions one by one. Let's start with the first one. So here we have multiplication of two mixed numbers. And the first thing that I do, because it's multiplication, I will convert them to improper fractions. So 2 times 10 plus 1. So we have 21 over 2 multiplied by now 22 times 1 plus 3. So that is 25 over 22. And it is negative, as you notice here, so I'll keep the negative there. But because we have a positive times a negative, I know that my answer overall will be negative. Okay, so now working through this, typically when it's multiplication, I will try to reduce, but I notice that I have 21 on top, and 2 clearly doesn't go into 21. And then I have 22 at the bottom as well. Well, I can't really reduce anything here, so I'm a little bit stuck. I'm going to have to work with these rather big numerators, and let's do that right now. So if I take 21 and I multiply it by 25, so I'll do that first. Now the order doesn't really matter, so we can do that. So 1 times 5, 1 times 2, and then 2 times 5 is 10, carry my 1. So 2 times 2 plus 1, and that is 5. So I can add this up. So 5 and 2 and 5. So that's going to be my numerator. So that's 525 all over. And now I have to multiply the denominators. So 2 times 22, which is 44. All right, so that's what we would do first. Now, most of the time, you would take these answers and then you would convert them back, either trying to reduce them or convert them back to a mixed number. So let's do that. So I'll convert this to a mixed number. So I want to know how many times does 44 go into 525. Well, 44 into 52 goes once. So here is 44. And now next, so I'm going to subtract these. Okay, so 52 minus 44 is actually 8 here. And then I'll bring down the 5. And now 44 into 85 goes in. I wish it could go in 2 times, but it will not, because 2 times 44 is 88. So it's still stuck at 1. So this is 44. And now subtracting this, so 5 minus 4 is 1, and 8 minus 4 is 4. So this is my remainder. So the overall answer here is that I have negative, so the number overall is negative. So the whole component, so that's from right here, is 11, and that leaves me with 41 over 44. And that would be your final answer for question number 1. Let's take a look at question number 2, which is this one. So now we have, so negative 4 over 9 divided by a negative, I guess, 2 over 27. So step 1, I'm going to count the number of negatives because this is just a division. So I know that my answer is going to be positive. So because of that, now there's no mixed numbers, so I am going to just straight and try to do this division. Division is multiplication by the reciprocal. So reciprocal is the swapping of the numerator and denominator. Okay, and now let's take a look So I can actually reduce this quite a lot. 9 goes into 27, so 9 into 9 goes once, and into 27 it goes 3 times. And then I have 2, which goes into 4 2 times, and 2 into 2 once. So this actually is 6, and it's positive. Okay, so that is the second question. All right, let's take a look at the third question. So this one, so we have a 1/4%, and we want to convert this to a fraction. All right, so since it is a percent, now this right here is already a fraction, so I don't have to do much there, but I do have the percent symbol, so I have to get rid of that percent, and in order to do that, we divide by 100%. So I have basically 1/4. Division, again, is multiplication. Okay, and this is 100/1. So we take the reciprocal, which is 1/400. And that would be the result for question 3 if we wanted to convert the percent to a fraction. All right, so question number 4. Let's take a look at that, which is this one. So we want to be able to graph. Okay, so the following. So let me do, so this number line. All right. So it is negative. So now let's stick, we need a 0 here. And it's negative 2.7. Okay, so it is lying somewhere between 0 and negative 1. Okay, so how do we do this? Well, so we have a fraction of 7, so I need to have 7 pieces that are cut up here. So let me zoom in here, and let's take a look at and try to create. Okay, so we have 7 pieces. Okay, so we have piece number 1, piece number 2, piece number 3, piece number 4, piece number 5, piece number 6, and number 7. And what I mean by pieces is these. Now, these are not to scale, so piece 1, piece 2, piece 3, 4, 5, 6, and 7. Okay, and they want, so it's negative, and it's, we have, okay, 2, so we want 2 pieces, so therefore we're going to be right here. So this is 2 negative 2/7. All right. So when you're counting, count the pieces and not the little lines, okay, that you see. And that's often people get caught up with that. So that's question number 4. All right. Question number 5, which is now this one. We want to evaluate this. So I have negative 4/9 plus 7/12. Okay, so this is addition, so I need common denominators. Okay, so I'm going to do my little table here that I like to do and just do prime factorization of these denominators. All right, so first, well, 9. So I know that I can reduce 9 by 3. Okay, so 3 into 9 goes 3 times. 3 into 12 goes in 4 times. And now next, so I'm going to try to get rid of this 3. So 3 into 3 goes once. Now again, remember when you're doing this table, what you want to do is you want to reduce each column to a 1. And then on the left-hand side here, those are the primes factorization, okay, of that particular column in this case. Okay, so what I notice next is the 3 does not go into 4. So I just keep it as it is. Okay, and I try to now use a different primes because I have the 4, and 4 is divisible by 2 times. Notice the first column, this column was done, so I do nothing with it anymore. And then, of course, 2 goes into 2 once. And that completes my second column. So the actual lowest common denominator is the multiplication, okay, of these prime numbers here. So 3 times 3, which is 9, 9 times 2, which is 18, and 18 times 2 is 36. Okay, so that is my lowest common denominator. So now I'm going to change my fraction here. 9 into 36 goes 4 times, so that's the multiplier. And then 12 into 36 goes 3 times, so that's the multiplier for the numerator there. And now I can just go ahead and add. So I have negative 16 plus 21. So that's 21 minus 16, okay, which is just 5. So my answer to this question is, well, 5 over 36. And it does not reduce any further. So that's question number 5. All right, let's keep going here. So question number 6, I guess it's a little bit harder now. So this one, so we have 1 and 1/2 plus 4 over 6 times negative 3 over 5. So again, remember, when you're solving, so I have an addition between here. So I have to first find out what the answer here is and what the answer here is to these terms, and then I can add. Now this one, okay, so what I have is 1 and 1/2, so I have nothing to do there as of yet. And this one right here, so I do have something to do. So I have to multiply these. Now, before I do any multiplication, so I'm working this, I notice that I have a negative, so that's going to change. Okay, so this positive and negative, so it's going to be actually negative. And I can also reduce. Notice that actually, well, the 4 and the 6, okay, can be reduced to 2 over 3. However, this 3, I notice, can be reduced with this 3. So this is going to be just 1. So what I actually have is I have 2 over 1 multiplied by, now again, remember the negative is gone because we put it there. So I have 1 over 5. So I can't really reduce this any further because I have a 2 and a 5 there at the bottom. So I have 1, 1/2 minus, okay, and then this is just 2 over 5. Okay, so this is what I have. And now I can go ahead and do this subtraction. Now, if, for instance, this number right here was very big, okay, I can just go ahead and just subtract the fractions and then see what happens. If it's very small, I can do the same. So what I mean is, let's try to do the subtraction. So I'm actually going to take, okay, so the subtraction between these. So this is 1, remember, plus 1/2. Okay, so that's what this is, minus 2 over 5. Now, some people will convert this right here into an improper fraction and then find the common denominator, which is fine. Okay, so you can do that. Now, I'm going to just take 1 over 2 minus 2 over 5. Okay, so finding a common denominator, you will notice that it is actually 10. So it's going to be 5 1/2 is 5 over 10 minus 4 over 10. That's 2/5. And that gives me 1 over 10. All right. So now don't forget, because it's 1 and 1 over 10. So my answer is 1 and 1/10. Okay, because this was positive. So that is question number 6. All right, so let's keep going here. Okay, so now let's take a look at question number 7, okay, which is this one. So this is basically, we're trying to figure out what we're missing right here, okay, this missing piece in the denominator. Now, actually this negative here and this negative here, okay, so in order to do this, because they are equal, I want to see, okay, how many times does 9 go into 27? So I am just finding a scaling, and it goes 3 times, meaning 9 times 3 would give me 27. Now, of course, it is negative because I have a negative symbol right here. So the negative and negative will cancel, and then the 9 and the 3 gives me 27. And if they're equal, then I have to do the same thing to the bottom. All right, so here I have, since I multiplied the top by -3, I'm going to multiply the bottom by -3. And that's going to give me my missing piece, which is 15. All right, so that is question number 7. Okay, let's take a look at question number 8. So now for question number 8, okay, so what I have is I'm converting, and this is a prefix question. And so let's do a little bit of kind of a deja vu here. So what did we have for prefixes? So remember, so we have a base unit. Now in this case, the base unit here is seconds, so S. Okay, and then we had all of these prefixes before. Okay, so going to the left, okay, we have deca, right? Then hecto, then kilo, then mega. Okay, now going to the right, we have deci. Okay, then we have centi, then we have milli, and then we have micro. Okay, and remember what these meant. Okay, so for example, deci is 10 to the -1, centi is 10 to the -2, milli is 10 to the -3, and then it loops over by 3s, so now it's -6. Okay, and on the opposite side, deca is 10 to the 1, hecto is 10 to the 2, or 100, kilo is 10 to the 3, or 1,000, and then mega loops into the million. Okay, so now what we want, in our case, we have milli. Okay, so we're right here, and we want to jump over back to the base. In this case, the base is seconds, so we want to jump 1, 2, 3 spaces. Okay, so to the left. Okay, and moving 3 spaces to the left, okay, is going to give us, so 0.0087. Okay, how did I come up with that? Notice those were the 3 spaces. So here, so I'm taking the decimal and I'm just going shifting 1, 2, and 3. Okay, so the answer for the first one would be 0.0087 seconds. Okay, that's that first one there. Okay, now let's take a look at the second one. So now we have, okay, so our base, so again, our base in this case is joules. So notice joules, J and J. And now the prefixes, so we are going from kilo. So we're right here, and we're actually going to go all the way to deci. So it looks like right there. So we're going to jump 1, 2, 3, 4 spaces in this direction. Okay, so 4 spaces in that direction. Okay, so let me remove this. Okay, and let me write it out. So 0.15, and now 4 spaces. 1, 2, 3, 4, and that comes out to 1,500 decijoules. Okay, so that's that second conversion there. Now, what about this last conversion? So my base in this case is m, or meter. Okay, so notice m and m. And then the prefixes that I have, I'm going from micro, or this little u, funny u, it's a Greek letter u. So I'm going from here, and I want to jump over actually to milli, so it's going to just jump over here. Now, the tricky part is that this jump actually constitutes of 3, because notice you're going from 10 to the minus 6 to 10 to the minus 3. Okay, and now you are going in this direction. So we're going to take 125. Okay, we're going to take the decimal, which is at the end, and we're going to move 3 spots, 1, 2, and 3, which is 0.125 millimeters. All right, so that converts those 3 examples, okay, and completes question number 8. Question number 9. Okay, so we want to know how many significant figures there are in this measurement, and then what is the estimated digit. Okay, fine. So it's a scientific notation. Now for scientific notation, all you care about is actually the mantissa. Okay, so you do not look at the power of 10. So now for the mantissa, so if we want to count the number of significant figures, well, we know that significant figures, okay, so non-zero digits always count, so that's the 4 and the 2. And now I have 2 zeros here, this 1 and 2. Now, do they count? Well, remember that the rule states that if there is a decimal in the number, then the zeros count. So that means I have 4 sig figs. And now, what is the estimated digit? Well, the estimated digit by definition is always the last significant digit. So in this case, it would be 0. Okay, that's question 9. Question number 10. So the same type of question, except we have not a scientific notation, but a regular number. So in this case, how many significant figures? Well, these 2 definitely count. Now these zeros do not count because they're on the right-hand side and there is no decimal. So in question 9, those zeros counted because they were on the right-hand side of the non-zero digits, but there was a decimal, so they counted. But here there is no decimal. So here I only have 2 sig figs. And my estimated digit in this case now is my last significant digit, and that would be the 5. Okay, that's question number 10. Let's keep going. Let's take a look and try, okay, to do the next one, which is question 11. I'm going to do question 11 here a little bit below. So I have 4 over 15 minus 11 over 12 plus 1 over 2. Okay. I do not have any like fractions here, so I need to find a common denominator. So that's the first thing that I'll do. So I have 15 and 12 and 2. Okay. So let's break these things down. So 15, so primes. Well, the first one is 3. 3 goes into 15 5 times. 3 goes into 12 4 times. 3 does not go into 2. So 2 stays the same. Next, Okay, so now I have 5. Well, clearly 5 is divisible by 5, and it completes my column here. Next, 5 does not go into 4, so that stays the same, and then the 2 stays the same as well. So column 1 is finished. Now column 2. Well, 2 goes into 4 2 times, and it goes into 2 once. So as a consequence, on working on the second column, I actually finished the third one because I see a 1. That leaves me the lonely 2 to reduce, and that completes my whole prime factorization of those denominators, which means that, okay, if I multiply these, I will get the lowest common denominator. So 3 times 5 is 15, 15 times 2 is 30, and 30 times 2 is 60. Okay, so that is my now denominator for these. Okay, so now I have the following. 15 goes into 60 4 times, so that's my multiplier. It's going to be negative 16. 12 goes into 60, you can check, goes 5 times, so that's my multiplier here. And 2 goes into 60 30 times, so that's my multiplier there. Okay. And now I have to go ahead and try to do this. So I have negative 16 minus 55, and then plus 30. So first these. Okay, so I'm actually really just adding, but it's going to be a negative. 6 plus 5 is 11, carry the 1, and that's 71. So this is negative 71 plus 30, and you can check for yourself, and that's going to be negative 41. So my overall answer here is going to be negative 41 over 60. 41 is actually prime. You cannot reduce it with the 60 at all. And that completes question 11. Okay, let's take a look at question 12. So now for question 12, I have 1 over 8, and I want to convert this to a decimal. So much shorter question than the previous one. 1 over 8 to decimal, I have to do long division. So I just have to divide. Okay, so this is not always fun, but we can do the division. Okay, so 8 into 1 does not go. And this is where we have to extend our zeros. 8 into 10 does go once. So 1 times 8 is 8. Subtract. So 10 minus 8 is 2. Okay. Now because we want a decimal, I have to keep going until I finish this. Okay, so I put in another 0. So the 0 drops down. 8 into 20 goes 2 times. So 2 times 8 is 16. Subtract. This is 4. Bring down another 0. And this will actually complete it. Okay, so the answer here is 0.125. Okay, great. That's question number 12. Question 13. So this one asks us about some prefixes. What does kilo, milli, micro, mega represent in powers of 10? Okay, so we actually did this. Oh, and I kept it there. So notice kilo right there. Kilo is 10 to the 3. Milli is 10 to the minus 3. Micro is 10 to the minus 6. Mega is 10 to the 6. Okay, that's million. So that is the powers of 10. Now, of course, you can evaluate this if you like. So 10 to the power of 3 is just 1,000. Okay, this, okay, because it is a negative. So this turns out to be that. So remember, 1, 2, 3. And you can do the same for 10 to the minus 6 and 10 to the power of 6. Okay, that's 13. Let's move over to the next set of questions. We want to convert 0.9% to a fraction. All right. So it is a percent, and we want to convert it to a fraction. So what I like to do is first I'll convert the decimal to a fraction. So 0.9. So that's 9. That's just 9/10. So this is 9/10. Okay, so that's what that would be. And now I have to divide by 100%. Okay, to get rid of this percent symbol here. Well, but that is just 9 over 10 multiplied by the reciprocal. So 1 over 100. And this becomes 9 over 1,000. Okay, and that would complete question 14. Let's take a look at question 15. So for question 15, I have negative 2. So let me write this. Now remember that, this division right here. So this just means divide, okay, by 7 4/5. Okay, so first of all, I know that the answer is negative, okay, because I have one negative sign. Now, when we're dealing with mixed numbers, we always want to change them back into improper fractions when we have divisions or multiplications. Okay, so, well, this just equals 2 over 1. Okay, and this, well, 5 times 7 is 35 plus 4. So that's 39 over 5. All right, and that's division. So now division is multiplication by the reciprocal. So this is what we have. 2 doesn't go into 39 and 5 doesn't go into 39, so there's nothing to reduce. So this is just now 2 times 5 is 10, and then 1 times 39 is 39. And then don't forget, it's negative. Okay, so that's question 15. Question 16. Okay, so this one looks a little bit harder. Okay, so let me just copy this question down here. So I'm going to bring it down so that I can work on it. Okay, and then I'll come back. All right, so what do we have? So we want to evaluate this. Okay, so negative 2. Now, I want to know, okay, what this bracket is, okay, because it's multiplication. Then I have, okay, an addition, okay, 3, and again, I have this bracket right here. So maybe what I'm going to do is, so let me first, so I'm going to figure out what this is. So I have negative 1 over 2, okay, minus 5 over 4. Now I need a common denominator. This common denominator is actually a little bit easier because the fractions are small. So that's 4. Okay, so that's going to become negative 2 over 4. And this will become just 5 over 4 because it stays the same, right? So 4 into 4 goes once, and then 2 into 4 goes 2 times, and that's what I did to the multipliers here. Okay, so that is equal to now negative 7 over 4. Okay, so I have the first one. All right, so let me just erase this. So this is negative 2 multiplied by negative 7 over 4. Okay, so that's that. So I can work with that. I can find out what this is. Well, negative times negative is positive. And now multiplication, so this is 2 over 1 multiplied by 7 over 4. So I can reduce the 2 goes into 4 2 times, goes into 2 once. And this becomes now 7 over 2. Okay, so that is this big thing right here. That's what I just found. Okay, so that right there is 7 over 2. Now I need to find out what this right here is. Okay, so let me start with the bracket. So this right here, 2 minus 1 over 4. Okay, so this is really like 2 over 1 minus 1 over 4. So finding a common denominator. Okay, so that will be 4. So this is 4 multiplier minus, and this one stays the same, and it gives me 7 over 4. Okay, so that's that bracket. Now, once I have this bracket, then it makes my life a little bit easier because I have now 3, and then in the bracket I have 7 over 4. Okay, so multiplying this, so 3 over 1 times 7 over 4 is 21 over 4. Okay, so now finishing this off, this is plus 21 over 4. I need a common denominator between 2 and 4, which is 4. Okay, so this just stays the same. This we have to multiply by 2. And it equals, so we have 14 plus 21. That's 5, 3. So this is 35 over 4. And now, lastly, okay, change it to mixed number. So 4 goes into 35 8 times and gives us a remainder of 3. And that is your final answer. Okay, so that was a long one, question 16. Okay, let's take a look at question 17. So for question 17, when is a number divisible by 2, 3, 5, and 10? Okay, so these were just the rules of divisibility. Well, a number is divisible by 2 if it is even. So that means it has to end in a 0, a 2, a 4, a 6, or an 8. Okay, next, a number is divisible by 3. This is if the sum of digits, okay, is divisible by 3. All right, so for example, if I wanted to check 192, sum of digits is 1 plus 9 plus 2. So that would be 12. Okay, so when you add them up, it's 12. So now you check, is 12 divisible by 3? It is. So it is, the 192 is divisible by 3. So that's the sum of digits rule. All right. Now number 5. This one's easier. So it has to end in a 0 or a 5. And when is it divisible by 10? If it ends in a 0. So those are your divisibility tests, okay, for these. All right. So that completes 17. Let's take a look at 18 now. All right, and I'm going to, so let's delete these. We have a little bit of space at the bottom. Okay, and let's come back to our question 18. So for 18, let me copy this down. Okay, so bring it down here. Oops. So let's copy this. Okay. So now we have a subtraction between mixed numbers. All right. So first, what I like to do is because I'm subtracting, I don't like to change to improper. In this case, it would give me a huge improper number. So what I do is I first deal with the whole numbers. So I have 213 minus 192. Okay, so let me do that. 3 minus 2 is 1. Okay, 1 minus 9 I can't do. Borrow this out. So that gives me 11 minus 9, which is 2. Okay, so that gives me 21. And now next, I will do 1 over 4 minus 5 over 8. Okay, so I need a common denominator between these. So that's going to be 8. Okay, so 4 times 2. Okay, and that's my multiplier minus. So this one doesn't change. And that will give me minus 3 over 8. Okay, so I have 21 minus 3 over 8. So in order to complete this, because I have this subtraction here, okay, then what I have to do is, okay, I'm going to break the 21 into 20 plus 1. And now what I can do is, okay, I can do this. Okay, so 1 minus 3 over 8. Well, the common denominator is 8. Okay, the number 1 is 8 over 8 minus 3 over 8, which equals to 5 over 8. Okay, so this is that right here, and it takes care of the subtraction, but I still have the whole component of 20, and then my fractional component of 5 over 8. And that will complete question 18. Let's take a look at question 19. We want to find the reciprocal. Okay, great. In order to find the reciprocal, we need to have fractions. This is not a fraction. So let's turn it into a fraction. So if I turn it into a fraction, it's going to be 9 over 5 because it's 5 times 1 and then the 4. Okay, it still stays negative. Now, if I want to take the reciprocal, negative stays, but I have to swap numerators and denominators. And that is your answer for question 19. Okay, let's take a look at the last one, which seems complicated. Let's see what we can do with it. So I'm going to paste it in here. Okay. So first, what I notice in this question, it looks intimidating, but I do notice that it is just multiplications and divisions. So in multiplications and divisions, what I like to do is, in order to solve them, is, well, number one, I will count how many negatives I have to see if my answer will be positive or negative. So I have 1 negative, 2, 3, which tells me that that's an odd number of negatives, so that means that my answer will be negative. Next, okay, so what do I do next? Number 2 is I don't want to have any mixed numbers. I just want to have fractions. So let me change all of these. So this is 4 over 7, that's already a fraction. Now this is not a fraction. Okay, because I got rid of the negative, I no longer need these brackets here. So I'm going to change this, okay, to a fraction. So 3 times 6 is 18 plus the 2. So that's 20 over 3. And these ones, so I have 10 over 12. These ones are already fractions. Okay, so that's step 2. Step 3, okay, I don't want to have any divisions. So I do have divisions here, and here. So let me change these up. Remember, division is multiplication by the reciprocal. So notice it's swapped. Okay, so the other ones stay the same. And then again, division. Okay, so I have that. Now, next step, reduce. Okay, because now I have only multiplications. Okay, I can reduce all the way across, and I can actually see quite a bit of reduction. So first, I notice that 4 will go into, for example, 20. So 4 into 4 once, and it goes into 25 times. So that's 1. I notice that 3 goes into 12. So 3 into 3 once, and it goes into 12 4 times. All right, so what else can I reduce? Now I have a 10. So I have a 10 here. Okay, and the 10 and the 5. Okay, so 5 goes into 10 2 times. Okay, so I have that. And now I also see a 2. Okay, and a 2. So that cancels. Let me just clean this up so that we see what's left over. 1 over 7 times 1 over 1 times, okay, so that was 1 over 4 times 24, and then there's nothing else. Okay, so these 2 and 2's canceled. So that's what I have left over now. Okay, well, 4 actually, so that 4 that I see here goes into 24, okay, 6 times. And that is pretty much it. So notice all you have left on top now is 6 over 7. Okay, and it was negative, and that would complete that giant question. So you have seen 20 different examples here of various degrees. Thank you for watching, okay, and go over these as much as you